Welcome to The Explainer. Today, we're doing something a little different. Think of it less like a math lesson and more like a heist. We've got this mathematical monster of an equation, and our job is to crack it wide open and find the simple secret that's hiding deep inside. Okay, so let's get right into it. Take a look at this thing. It's a ninth-degree polynomial, which is really just a fancy way of saying it's an absolute beast. I mean, seriously, finding the x that makes this entire monster of an equation equal 0? It looks completely impossible. Like, where do you even start? So this is why we're calling it a heist. This equation, it's basically a high-security vault. It's built to look scary, to keep you out. But our job is to find the perfect tool to crack that combination and see what's really going on inside. And listen, for a vault this complex, your average everyday lockpick just isn't going to cut it. Nope. But lucky for us, there's a very special key out there. A master key, if you will, designed for this exact type of lock. And that key, that's our way in. And here it is. This is our master key, the Mourad Sultan Ezouidi discriminant formula. Now, don't worry about the name, and you definitely don't need to be a master locksmith to use it. You don't have to get bogged down in how the key is made, just what it does. And what it does is tell us a critical secret about the solutions to this equation. The x values we're hunting for. Mathematicians call them roots. All right, here we go. This is the heist itself. It's time to put that key in the lock and give it a turn. We're going to apply this formula to the numbers sitting in front of each x. Those are called the coefficients, and we're going to see what this vault starts to tell us. So we use the formula for the first time, and boom, the result is 0. Okay, that's interesting. Let's try it again. Apply it a second time, and we get 0. Again. A third time? Yep, you guessed it, 0. Now, something is definitely going on here, right? A pattern is emerging. Is this just a coincidence? Let's find out. Well, it turns out it is absolutely not a coincidence. Because as we keep going through all 9 steps of the analysis, the result is the same every single time. It's just 0, 0, 0. It's kind of shocking, really. You can almost hear the tumblers in the vault's lock clicking open, one by one. And this just shows you the pattern perfectly. This isn't just random static or noise. No, it's a crystal clear signal, a perfect unbroken chain of zeros. This is the clue we've been looking for. The vault is practically whispering its secret to us. So here's the kicker, the really crucial part. That string of zeros, it's not just a number. It's a message. It's a code. And what that code tells us is that all 9 solutions, all 9 roots of this gigantic, messy equation are actually the exact same number. Suddenly, our impossible problem just got a whole lot simpler. So we've cracked the first part of the code. We know all 9 solutions are identical. The big question now is, what is that number? We just need to figure that out. So let's follow this clue and see where it takes us, because it leads right to the final answer. So our huge, massive investigation just got boiled down to one single question. We're not hunting for 9 different mystery numbers anymore. We're just looking for one. And the craziest part, the clue to what that number is, it's been right there, staring us in the face from the very beginning. Yeah, let's rewind all the way back to the start. Look at the second part of that massive equation. You see that number? The minus 27? Well, that's not just some random number thrown in there. Nope. That is the final piece of the puzzle. You see, there's this really cool rule in math. It's called Vieta's formulas. And what it tells us is that this specific number, the one attached to the second highest power of x, is tied directly to the sum of all the equation's roots. So for us, it means the sum of our 9 identical roots has to be 27. And just like that, that's it. We have everything we need. The lock is officially open. It's time to swing that heavy vault door wide and see the treasure that was hiding behind all that crazy complexity. So just think about this for a second. Our problem is no longer some insane 9th-degree polynomial that would make a supercomputer sweat. It's now a question you could solve in, 3rd grade. 9 identical numbers add up to 27. What's the number? I mean, that's just 27 divided by 9, right? And there you have it. The answer is 3. That one simple, elegant number was a solution the whole time. It was just hidden inside an equation that was designed to look impossible. The treasure inside this vault, it wasn't gold or jewels. It was simplicity. So let's just recap this whole heist, right? The main takeaway here is the process. We started with this super intimidating vault, our polynomial. We used a special key, the Ezouidi formula, to find a clue. That clue, the repeating zeros, told us a secret about how the lock worked. And that secret, that all the roots were the same, let us walk right in and find the simple treasure. And that's really what's so cool about this. It wasn't about using brute force or supercomputer. It was just about having the right key and the right way of looking at the problem. It kind of makes you wonder, doesn't it? How many of the world's most complex problems are just like this? Just big, scary vaults waiting for the right person to come along with the right key to reveal a surprisingly simple solution.